Good evening, everyone. It is once again Ted the Speed Learner, and tonight I'm going to cover the subject of molten salt batteries. Okay? The first thing I want you to focus on, or the one thing I will focus on in this particular video, is why this battery was constructed. Do you recall a video I recently uploaded where I discussed dendrites? For those of you who have been on my live stream, you know that was the last video I did. But anyway, if you're not on my live stream, you know I just did a video recently about dendrites. These dendrites can gradually degrade lithium batteries. That is true. They can even cause lithium batteries to ignite if enough of these dendrites collect inside the electrolyte of a lithium battery. That's why some companies are experimenting with molten salt batteries. The electrolyte of these batteries is comprised of a compound that contains sodium chloride. What is sodium chloride? At first, this chemical sounds ominous, but you may have a large quantity of this compound in your kitchen. Why do I say that? Because this compound happens to be table salt. You're like, wait, what? Sodium chloride is actually table salt? Yep. I should have known that. You could buy that for less than $5. So you're like, wait a minute, what? What is in table salt? Well, obviously there is sodium in this compound. What other substances are in this compound, this sodium chloride? Well, another material that can be found in this compound is chloride. But chloride should not be confused with chlorine. Actually, chloride is created when an extra electron attaches itself to a chlorine atom. So if you have a chlorine atom and you attach another electron to it, it becomes chloride. Then the chloride attaches itself to other atoms like sodium to form compounds. Hence the name sodium chloride. But molten salt is comprised of more than just one compound. Another compound in molten salt is potassium chloride. So you got your sodium chloride and your potassium chloride. So you got lots and lots of chloride. Okay? Although potassium chloride is used as rock salt to melt ice in the wintertime, it can also be used in agriculture to process food. You can look this up for yourself. If used properly, it can lower a person's blood pressure. If used improperly, it could be perilous to use, if you get my meaning. Now, molten salt contains sodium chloride, potassium chloride, but it contains something else as well. The other compound is aluminum chloride. You're like, oh man, another batch of chloride? Yep. And yes, I'm referring to the aluminum that you would find in aluminum foil. Now, this whole discussion leads to a discussion of Michael Faraday. And I know you're like, oh no, he's going to talk about a guy named Michael Faraday. No, really, I'm not. I'm going to let you research that, okay? Because I don't want to spend a lot of time talking about the history of Michael Faraday. Maybe I will in a future video if you ask me to, but right now that's not exactly what I have in mind. But I will bring up the topic of the Faradaic exchange current. What the heck is a Faradaic exchange current? When electrons travel from one electrode to another, this process is called a Faradaic exchange current. That's from what I understand. If I'm wrong, you're more than welcome to correct me. A high Faradaic exchange current is a current where electrons are moving very quickly from one electrode to another, as far as I know. If I'm wrong, feel free to correct me in the comments down below. These molten salt batteries possess a positive elemental chalcogen electrode. Other batteries possess a low-capacity compound formulation electrode. These molten salt batteries lower the chances of dendrites forming on the aluminum electrode and ruining the battery. And in the description of this particular video, you will find a link that will take you to an article that would discuss molten salt batteries in greater detail. So feel free to look that up for yourself. I want to thank you very much for watching this particular presentation. I will tell you more in a future video, so I'd like for you to stay tuned.